specifications don't apply. But if you design, if you go to work down the road here for Northrop Grumman, who are designing the B-21 down there, you might use some of these specifications. The performance specification, which really only talks about a couple of things. It talks about airspeed calibration, it talks about stalling speeds, and that's about it. Because most of it, for performance in particular, is in the contract. They say this thing's going to go warp 6, and you better, make sure that it does. For stability and control, which we'll cover, we covered last spring, we'll cover again this spring, I guess. That's MIL F8785D, although since most of the new airplanes are fly-by-wire, it comes under MIL 1787. The handbook specification covers a lot of the performance things. It gives you all the speeds and that sort of thing that you need to make a handbook, like a pilot's handbook. Well, if we have a new airplane, it rolls out and it's handed to the flight test group, how are we going to approach this thing? Well, the first thing you're going to do is probably some shakedown flights. That includes first flights and all that. And I can tell you that way too much hoopla is made about a first flight. If the thing looks like an airplane these days, it'll probably fly. But I'm a believer that on a first flight of a new airplane, you should learn as much as you can. So, when you put this together, you do quite a bit of things. But shakedown flights, that includes high-speed taxis and all that sort of thing to get ready for the first flight, and then the first flight and any flights that you do for systems like raising or lower the gear and all those kinds of things. But then the very next thing you do is the airspeed calibration. Why do you do that? Anybody have an idea? Why do you do that first? Almost, the first real thing we're going to do.
So you can figure out what all your other speeds are from that, stall speed.
Yeah, the next thing we're going to do is stall speed. And so we need to know that what we're reading is really correct. So we do an airspeed calibration. Now, up until recently, and by the way, when I say recently, that's in my lifetime, okay? For you all, it may have been before your lifetime, okay? But fairly recently, GPS wasn't, when I first started doing this, there wasn't any such thing as GPS, okay? Nobody had even thought about it. I guess I did my first airspeed calibration using GPS in 1992. At that time, you had to wait until 3 satellites got in view before you could do anything. Because it took 3 to be able to get that sort of thing. Today, everybody's got a GPS. Most of you probably have one on your phone. But in the 80s, we didn't have GPS. And the airspeed calibration in those days, there were a couple methods, and we're going to talk about this later in the course, but there were just a couple of methods that you could use. And they all required flying close to the ground. Now here you are in a new airplane, that you've just had the first flight. You don't know if the engine, how reliable the engine is or any of this stuff, and you're out there flying maybe one wingspan above the surface of the earth. It was one of the most dangerous things in the whole flight test business was an airspeed calibration with a new airplane. Today we have GPS. We'll do a GPS airspeed calibration in this course. We'll do it at altitude. Okay. Stall speed measurement. Hey, here's another thing. We don't know how this thing stalls. We don't know what the stall characteristics are like. It may want to get on its back in a hurry when it stalls. But we need to know what the stall speed is in order to comply with the regulations, which are all based on some multiple of stall speed. So the second thing we're doing is stall speed measurement. Maybe not quite as dangerous as the airspeed calibration was, but still yet, you know, there's a chance you might lose control of the airplane. Then we're going to expand the flight envelope. Now I can tell you that for a first flight, I generally like the center of gravity to be at about 20% of the mean aerodynamic chord. Okay, why do I do that? Well, the neutral point of the wing we call the aerodynamic center, right? Classes you've heard, and that's where? 25%, right? Or give or take a percent. So I like to do my first flights at 20%. Don't want them too far forward because I might not have elevator enough to rotate the nose. So I want it fairly, you know, but I want some stability. I know that if I'm at 5% ahead of the aerodynamic center of the wing alone, that I'll have 5% static margin, as we call it, in order to safely fly the airplane. And, you know, the tail is going to add some more stability and that sort of thing, but generally we'll start out there, but then we've got to expand that envelope. If you had to fly that airplane at 20% of the mean aerodynamic chord all the time, wouldn't be a very useful airplane. We go back to that first thing we were talking about, the mission, right? You know, probably wouldn't sell if you had to fly it there all the time. So we're going to expand the envelope. We're going to, you know, move the CG back and forward and that sort of things. And we're going to increase the speed. Probably on that first flight, we're going to have a limit speed of maybe 150 miles an hour. Generally, the structural dynamics folks will tell us, you know, we don't know what your flutter speed is, so, you know, we're going to limit you to 130 knots, 150 miles an hour for the first series of flights. After that, we're going to start, you know, after we've done these first flights, we're going to start expanding the airspeed envelope and the acceleration. You know, most of the first flight's going to be done at 1G, you know, like sitting here in this room. And we're going to expand that, and we're going to expand the center of gravity from 20% MAC to probably as far back as we can get it. Okay, so that's the first thing you're going to do. Then we're going to measure the performance. And you say, wait a minute. This is a performance class, and we're having it first. Why is that? Just because I decided that was the way it was going to be. All right. And I wrote it that way in the book. But you're going to do it this way if you're really doing the flight test on a new airplane. And here's why. I can tell you that if you work for a company, the sales guys, before this airplane ever flies, has already sold hundreds of them. Okay? And they have sold them based on how it performs. Performance sells airplanes Stability and control and handling qualities make them classics. They make the pilots love them, okay? And let me give you 2 examples. One airplane is called the Bonanza, it was built by Beech. Very good performing airplane, okay? Another airplane built at the same time, and these were built right after World War II, built at the same time, was the North American Navion. The North American Navion was built by the same group of people who built the P-51 and designed the P-51, okay? You know, famous fighters. However, the Navion has just great handling qualities. People who own them just love them because they're so nice to fly. The hell of it is they're slow. Okay, they are slow compared to Bonanza. Now, Bonanza's handling qualities are not very good, okay? In fact, it has a mode, particularly the one with the butterfly tail, has a mode that I call it the airsick mode. You got somebody in the back seat, you know, the old Dutch roll, as we call it, and you got in turbulence, it'll sit there and do that all the time, and whoever's in the back will invariably get sick. Navion, nice, stable airplane, nice to fly. Which one is still in production? The Bonanza is still in production and has been in continuous production since it was built in 1945 till this very day. The Navion has been in and out of production a whole bunch of times and is not in production today. Okay, so performance measurements get put off. But what I can also tell you is this: the pressure on you as the flight test person to measure performance first is tremendous. Okay, they are going to be on you every day. How fast, you know, how fast does it go? What is the rate of climb? You know, on and on. How short does it take off? And you're going to answer, we don't know. And that is going to, boy, they're going to run to the president of the company and scream and cry and carry on. And he's going to come back and lean on you, you know, to do it. And I can tell you what will happen if you do this before this. You will have to do the performance over again. Let me tell you about a company that did that. They built a little airplane called the Tiger. Grumman Tiger, okay? And the sales guys were in charge, so to speak. So as soon as they got, you know, just basic flying out of, you know, before they got those first three items done, they went out and they measured their performance. Came back, you know, reduced all the data, did all that work. A lot of what you'll find is there's a lot of work in performance data, okay? I hate to say it, but it's true. Come back and they put the performance data on the sales guy's desk, you know, and they were happy and they ran out and sold a whole bunch more airplanes. Then they started doing the envelope expansion and found that the horizontal tail was not big enough. It needed to be bigger, and so they made it bigger. Well, what did that do to the performance numbers they'd just given the sales guys? They were junk. So they went back out and remeasured the performance again. But it was a twin-engine airplane, and they had failed to see how big the rudder needed to be, to see what the minimum control speed was, and so then they found that the minimum control speed did not meet the rule, was too high. which meant that the vertical tail got bigger. Well, what about that second batch of numbers that they give to the sales guy? Again, in the trash. 3 times they did the performance before they got it right. Now, cost. Time is money. In almost any business, it's particularly true in the aviation business. The longer it takes to develop something, the more it costs, the least likely you're to make money. And hey, we're in the business to make money. So, one of the things you need to take away from this class is that you don't do performance first. You do it last. And the sales guys will hate you, okay, because you don't give them the answer. And I'm not, I can't overstress this. Okay, well, some other things, spins and high-speed dives come late in the development, and you might ask why. Well, one of the reasons is high-speed dives, that's structural dynamics. And if any of you taken a structural dynamics course, you know it's pretty mathematical intense, right? It takes a long time to get the answer. So that's why it comes last. But there's another reason too why both of these are put off to last, and that we call the test pilot's longevity rule. Okay? Those are the 2 most hazardous things that you do in this business. So you put them off to the very end of the program so you live longer. Okay. Well, after you get all that done, then we're going to certify the airplane. Okay, then we're going to get the FAA. Now you'll notice that the certification test is a little bit different. First, you have to get the FAA to approve your test plan. And by the way, you should have done a test plan on the previous set. But this test plan will be a little different because all it does is say, I'm going to use, I'm going to comply with this regulation in this manner. Okay, that's what the FAA test plan does, and it goes through all that. So you send that in to the FAA, and they look at it, and they'll probably send it back to you and say, you need to change this, you need to change that. After that goes back and forth a few times, they'll finally approve it. And they will also, you have to send in your test report that has done all of those things. You can see this gets expensive. You send that in, they will review that, and then they will decide what they want to test. They won't, in most cases, the FAA will not do the complete series of tests. However, if it's the first time you've done this, if you're a brand new company and it's the first time, they will probably fly all of the tests, okay? But if you're not a first time, when Piper sends in a test, or for instance, the thing I did last week for the people up at Thrush in Albany, Georgia, in fact, the FAA delegated me to do the test. I'm a designated engineering representative, test pilot, flight analyst, and they delegated me to do the test. FAA pilot never flew the airplane. One of the reasons was they were not qualified. They don't have anybody in the FAA in Atlanta who's responsible for this airplane who is tailwheel qualified, particularly for a airplane that has 800 shaft horsepower and carries over 5,000 pounds of weight by itself. All right. But anyway, after they have reviewed that, they'll decide what they want to fly, and they'll issue this type inspection authorization. And if they're going to delegate it to somebody, that's where it will be done, in this type inspection authorization. That's what TIA stands for. Then the inspectors will have to perform a conformity inspection. That means, they come and make sure that the airplane complies with the drawings, that it's built like the drawings say it was. Then, if the FAA is going to come and fly it, they'll probably do some familiarization flights so they get familiar with the airplane. Again, airspeed calibration comes first, stall speed measurement second. That's pretty much the same, but then it diverges from what our development test. They will probably look at engine cooling and other things to make sure they're going to do that. Then they will do performance first, because the requirements deal with performance. So they will do the performance stuff first. Then they will look at handling qualities, forward CG stability control, aft CG stability control. If the airplane is a single engine airplane and requires spins, they will be done then. Dives to the dive speed. And I can tell you that those are the two most hazardous things. I have jumped out of airplanes for both of those tests. And then, depending on the program, there may be some special tests. A lot of programs, particularly big airplane programs, they have 3 or 4 airplanes involved in the flight test. And so then they have a dedicated performance airplane, and they have a dedicated avionics airplane. That's, that kind of thing that, so these are all running in parallel. And then the last part, again off the chart here, is called function and reliability. The FAA on a new airplane requires that you fly it a certain number of hours to make sure that it performs as it should, not just initially, but after having been flown a while. Well, we're going to have to instrument the airplane, and by the way, this lecture is in not any particular order. You're going to instrument the airplane before you fly it, probably. Types of instruments. When we talk about air data, what we're talking about there is airspeed, altitude, ambient temperature at your altitude. Okay, so that's the air data. You'll find in this course that you're going to be collecting all 3 of those things. The next thing you're going to be collecting is power indication, or thrust if it's a jet airplane. In this course it'll be power, and for power we generally get RPM of the propeller and manifold pressure of the engine. Okay, those 2 things, and from that we'll got a chart. We'll go into the chart and determine what the horsepower was. Acceleration, normal acceleration, or G as it's sometimes called. Also, it may be X, Y, and Z acceleration. All 3 is a possibility, depending on the type of test. Fuel flow and fuel consumed. Fuel flow to determine airplane range. Fuel consumed to determine what our weight was at a specified data point. And we have in the Cherokee 6, we have a fuel counter that tells us how, if we remember to reset it after we fill the airplane up, if we remember to reset it, how much fuel we've used. If we fail to reset it or what have you, what we can do is we'll fly the flight, come back, fill the airplane up, and just, and then essentially do a straight line, so many pounds per minute, and calculate what our weight was at a given point. So then you're probably going to, you need to record time. If you fail to do that, you'll need to record time. I was flying this Thrush Ag plane last week, and one of the things I had to do was climbs. Well, this is a single cockpit airplane, okay? It's got a big hopper up in front that you fill with water or some other fluid if you're actually doing spraying. I don't do spraying, but I have to measure performance, and so I may have 400 gallons of water in the hopper. It's a lot of water, by the way. And, but I have to record data every 30 seconds and fly the airplane. They're really busy. You'll see, we'll do that in this course, and you'll find that you're pretty busy writing down the altitude, you know, the time, the altitude, and power, and all those kinds of things. And determine, you know, and then you gotta know the weight of the airplane, or you're gonna read it, or you're gonna fill it up when you come back. Oh, you make one mistake, you've just wasted the whole flight. Okay. Fuel flow and fuel consumed, control, position, force. This is all primarily for stability and control. We won't be doing that.